if y equals to cos with the angle 1 plus x squared. Prove that the second derivative minus 1 over x times its first derivative plus 4x squared y equals to 0. So what we need to do is we're going to find its first derivative and second derivative. So for the first derivative, differentiate with respect to x. Differentiate cos. We have two steps here. Which is differentiate trigo. Differentiate cos, we will get negative sign. And another step, differentiate its angle. Differentiate its angle, differentiate 1, 0, differentiate x squared, we get 2x. So we will have negative 2x times with sine 1 plus x squared. In order to find second derivative. So look at this first derivative. We have a linear here, multiply with this another function, which is trigo. So when linear multiply with trigo and we want to differentiate, means we need product rule. So product rule, salin yang depan, differentiate yang belakang, tambah salin yang belakang, which is sine 1 plus x squared, differentiate yang depan. So salin yang depan, which is negative 2x. Salin depan, differentiate belakang, salin yang belakang, differentiate depan. So salin differentiate yang belakang. Differentiate sine will give us cos. And don't forget, differentiate trigo got two steps. When you differentiate sine, you get cos, and don't forget its angle. When we differentiate its angle, we get 2x. Then continue. Salin yang belakang, differentiate depan. Depan means we refer to this negative 2x. Differentiate this, we get negative 2. So as we simplify, because these questions is asked us to prove that, so we try to see whether we can substitute back. So from just now dy dx, we can't get back the questions, but as you can notice here, d2y dx squared, we can substitute our dy dx and our y to prove this equation. Move everything back to the left hand side. So for this term, we can see this is clearly negative 4x squared cos 1 plus x squared. And at the back here is negative 2 sine 1 plus x squared. Compare back to the question. As you can see, what do you need to prove here? They are in terms of x and y and dy dx. So try to see whether we have cos 1 plus x squared. Try to see whether we have this term. So when we look at cos 1 plus x squared, so this part can be substituted by y. So we are doing multiplication method. We modify this equation until to this pattern. So another part here, 2 sine x. So from the first derivative answer, we know that dy dx is equal to negative 2x sine 1 plus x squared. So what we need here is negative 2 sine 1 plus x squared. The x here, we will move back to the left hand side. It will be equals to 1 over x dy dx. As you can see, we are getting nearly to the question. As you can see, the dy dx terms already appear, and then y term also appear. So what we need to do now is just move everything to the left hand side to achieve the equation. So this is our second term, minus 1 over. So when I move this to the left hand side, it will plus 4x squared y shown.